Hello explorers and welcome to another video. Today we are going to talk about high availability and scaling with some handover or failover. So in this video we are going to talk about two technologies, one called Heartbeat, which will look into different machines and see if they are available. So it's pretty much that the machine gives off a heartbeat, and if another machine sees that that heartbeat ever stops, if the machine is unavailable, if the service is stopped, it will take over the service of that primary machine. So you have one primary machine and you can fall over to or fail over to that secondary machine. And then we are also going to talk about distributed replicated block device, which is a built-in system in Linux where you can handle this failover by having a replicating disk over two machines and one of them being active, and when the failover happens you will get the other one active. So if you have a website where you actually save material such as files or upload files, you produce files and so on, you can have a failover and have the same data on two disks. So it's not that they share one disk, it's two separate disks on two different machines, but they have similar data or synchronized data. So let's jump into Linux here. So first off, we have a built Linux and it's just one VM1 and one VM2. Standard Debian installations, nothing fancy about them. And if we look at DF here, we see that we have one disk mounted, and I think I have some swap mounted as well. But the swap is a large part of the disk, so I actually want to use some of this swap as a part of my disk. So let's give myself root privileges here. So now I'm root there. Let's give me root on the other machine as well. So now that I'm root, I will actually do a swap off. So I will turn off the swap partition and I will do that on both machines. And this is pretty much just the setup I have in my machines at the moment. And it's just so I will free some space. If we do fdisk on this device and we look at it, we see here that I have 1 or 2 gigabytes of my main system, and then I have 7 gigabytes of other memory, and all of it is used by the swap partition. So I will actually delete that swap partition and I will create a new one, a primary one, and I will say that it should be start there and be 1 gig. So we need to do plus 1 gigabyte. And if we do check there, we have 1 gigabyte Linux file. The only reason I take 1 is because I don't want the sync to take too long time, because it can be a lengthy process. So I've set that up and I could use the rest for swap, but as this is just a demonstration, I think that is not required. Probably this setup here that I do is not required either. I just wanted to show you that we have 2 equally sized disks on 2 machines created. So that's our starting point. Now we want to install some packages. So I want to install Heartbeat and DRBD utils. So DRBD is already in the kernel, but I need some utils in order to handle the different things that have different utils. I can turn on and off things and create new disks and so on. So let's run a quick installation of these two systems here. Should not take that long. And when we have installed it, we need to configure Heartbeat. And Heartbeat is configured by a configuration file called inetc ha.d/ha.cf. So that's the configuration file for Heartbeat. So now I have installed these packages on both machines. So let's continue with the configuration. We go into etc HAD and the HACF is the configuration file. And here I will just copy in the configuration that is on the Git repository that I will give in the link in the description of this video. So I will copy that in here. Let's buy the etc HAD/HACF here as well, and put the configuration in here as well. So what does this say? We first off say that the log facility should be local 1, which means that it should not have its own log file. It should give the logs out to our system messages, so we can follow that in our message log. Then we have an auto join none. We say that if it's not, the node is not specified in this file, it's not welcome into this arrangement here. So the machines that should talk to each other should be node VM1 and node VM2. No other nodes are allowed. Then we have a warn time of 5. So that will send a warning message after 5 seconds that I can't find the other node. It's missing. And we have a dead time of 15 and an init dead at 60. So these are different levels of how soon should I react to something that happens. Keep alive is 2 seconds. So if things is not available after 2 seconds, I will start my session up instead. So that's the handover part. And these can be changed, and they can be changed to float values. You can have less than a second of fallback, depending on how your system is set up and how important the uptime is for you. If you have less than 1 second requirements, perhaps you should have multiple live machines that are answering to calls, and this failover or failover is perhaps not for your system. So it all depends on the load on your system and how much uptime is required for your specific installation. Then we have some way for these servers to communicate. We use ucast on the device of the server. So I have the same device on both of these installation because these are virtual machines, so they have the same interface. And these are the IPs here. I believe that I actually got new IPs as I installed a new here. So let's do 14 and 15, which I believe is the IPs of the new system. And then you have auto fallback on, which means that if the first node is not responding, take the second one or start the second one up. And so let's do the change in this file as well. Let's see, 14 and let's say 15. So let's save those files here. We could just for do an IP address show, just so we see that we have those values. There we have the device and we have our IP address here, 15. So that's how you get those. And it's important that your system has a name. VM1 and VM2 is the host name of my system. So I do host name, VM1 or VM2, for instance. So it's important that each system has a host name because that's used in order to identify that host, of course. Next up, we need some keys. So this system knows who's allowed to talk to me and who's not. So let's go into the auth keys. So that's HAD/auth keys. And this file should just have this simple little annotation here. This is auth1, and the first key is a SHA-1, and it is just a SHA-1. So you can create your own SHA-1. This specific key I have here is just something I created and I put in here. And it's the only thing that is required is that they have the same key. But if you is setting up a production environment, this key is secret and you need to create a good one. Perhaps you can use SHA-256 instead, so you get a longer key, more bits, and it can be safer. But as this is just a little test, I can have whatever key I like. So auth keys is the name of the file. And let's copy it in. So both hosts have the same keys. Next up, we need a file for our resources. And this is in etc HA resources. So that's the file. And the only resource I want here, and this is a system service that you want to have in here. And I say that the default, I want VM1 to be running the shared drive. So that's the configuration of HA resources. And we do the same for this system, HAD, HA resources. And I will put that in there as well. And let's see. Now, I have the resources, and you can have multiple resources in that file. So a lot of different services that you want to turn on and turn off depending on the handover. So in the normal case, the first VM, in my case VM1, will be the primary VM, will have this shared drive mounted and running, and the service running. You could, for instance, have Apache as one of your services, and that should be running on your host. And when the failover happens, or if the machine goes down, the second VM would notice that and bring up the services on that end. If the one machine comes up again, the services will be started there instead. So these are the handled resources between the machines. So let's go for the next. I want this drive to be mounted somewhere. So I will call that shared FS. So I will create that on both machines. And then I need an actual service to handle this. So in order to create a service, I will create a little bit of a script in my initd directory called shared drive. So that's the service name. And so let's start that up on both machines, and I will copy in this code here. It can be intimidating because it's a little bit much if you haven't seen that much of a bash script, but it actually is very simple if you have done some development before. The notation can be a bit wonky, but it's pretty self-explanatory. So it's a bash script. So this is what we say up here. The first param here, so we actually set a variable param, is to the first param in the what you send into this script. So if I say, for instance, start as the first parameter, this variable param will have start in it. And then we have an if statement here checking if start is the param. And then we will do these things. When on stop, we'll do these things. Then you need also to handle status, because that's a thing that a service can do, and we will not do anything there. And anything else, we will say that no such command. So what we will do on start is saying that the DRBD admin will tell this system that the test configuration will be primary on this system. So we will make this system the primary system, and then we will mount the device DRBD to shared FS. And we haven't created that one yet because we haven't configured DRBD, but that is what we are going to do next. And if we stop the service, we need to unmount this shared FS and make this specific machine the secondary one. And in a DRBD, if you are primary, you hold the data, you are writable, and you can handle and actually change things up. If you are secondary, you will only replicate data over from the primary. So you will not have anything that can be writable or can be changeable in any way. That's why we unmount it and make it secondary, because then you can't edit it until you become the primary node. And that is just so you don't have any conflicts and so on. So that was the script. Let's save that down. Both systems, so now both systems has that script. Next up, we need to make the script executable. So I say that this should only be executed by root or the system. So 7 says that it should be read, write, executable, and then 0, 0 is for group and user, and those should not have any rights to read or run this command. Next up, I want to configure DRBD. So in the DRBD directory, so in etc DRBD.d, you have a global common configuration. And I want to make move this away because it has a lot of things in it. If we look at this, it's a lot of configuration. And you have a lot of comments and good things. So if you are going to start with this, you can read up here and understand what each things are. But we are going to use a very small subset of all this. So I will move this to the side so we can keep it if we want to read up, but I will not use it. Oh, I need to be in the DRBD directory first. So now we want to create a new file here for this configuration. So let's do that on both systems. And the configuration I will put in here is very simple. I want to say usage count yes. You can say no or just leave it out. And this is just to tell the maintainers of the system that I'm a user, so they can count and know how many people are actually using this. And then we have this little common clause here that we say that the net should use the protocol C. And that is not that explanatory, but protocol C is the last of them. You have A and B and C. And C is if you have two machines that are very close to each other so that their replication are easy. If you are having A, it's a synchronous communication between two hosts that are far apart. So it will handle a synchronous communication and synchronous replication over the network. And then you can have B, which is asynchronous, using a lot more memory. But we will use the most simple one, C, which will replicate on a closed network. So let's put that into both systems here, and I will copy that and put it in here. So now both systems has that configuration. Next up, we need a resource or a drive or something like that. And this is in the same directory, and I will call it test. You saw earlier that we brought test up and down. So this is the resource that DRBD will handle. The file name is perhaps not important because we will in the file later on tell it the resource name. So here we have the resource test. It will use the device DRBD 0. So that was what we wanted to bring up earlier or start and also make secondary. And then we have the disk, and I will use SDA2, and that was what we created earlier. And I will use the same disk on both devices. And if you are not using the same one, you can put it in any of these clauses and have different ones, because this is what's currently available on VM1, and this is what is configured on VM2. And then we have meta disk internal, so I will put the meta information in the actual drive. It will not take up that much space, and I don't really see the reason why you would put it anywhere else, but you can have it external as well. Then I will add the IP addresses of the two hosts and give it a port number, and I think the standard port number for this is 77889. So this is the new configuration for this, so I will put that on both systems. So now we have a configuration for this test resource. Now we need to create the actual device, so we will do that on this system, and we will also create it on 2. So now we have created the service on both systems. We will bring up the DRBD service on both systems, and you see here that you are the 54th user that we have installed this version. So I guess this is a pretty new version, or perhaps some people don't want to be counted. And if we do an LSBLK, we can see that we have the block devices here, SDA2, and we have this DRBD 0 connected to that, and that's the actual disk that we can use later on. And if we do a status test here, we see that it's secondary and it's not inconsistent. And if we do the same on this, we see that this is also secondary and inconsistent. So both of them are secondary and inconsistent, which is something that we don't want. So now on the first host, now we have done everything similar on both hosts. Both hosts are exactly the same, but on the first host now I will do DRBD admin primary force on test. And if we do a status on this, then you see that this now has the role primary, and the peer is the secondary one, and it's not synced yet. It's at 0.66%. So that's the status we have now, but we still don't have any operating system on this. So I will actually go in and create an operating system here on this device as well. So now we have a file system on it. It's an ext4, so this is a journaling system, and it's pretty recent. It's not the most newest one, but I think it's very decent for storing a lot of data in a safe manner. So now we have that up and running. So now we just need to wait for these to actually be consistent and synced with each other. So that will take a little bit of time. So let's wait for that. And now we're back and we have these synced up. You see that this is the secondary one, so it's on number 2. And if we look at the primary one, we see that these are synced up and they are actually running well and are up to date. So now I want to do service heartbeat start. So I actually will start the heartbeat service on this machine, and I will also start it on the secondary machine. So now we have the heartbeat started. If we do a status here, we can see that it failed. Bad permissions on key file. So that's not good. Let's correct that. Heartbeat, and we will do a chmod 660 on auth keys. So we need to restrict the auth keys so not everybody in the system can read your authentication keys, because that would not be good. So let's do the same here. cmod 6700 auth keys. So let's restart the heartbeat and do status here. So now it's up and running, and this is important. It's active. It's actively running on this machine. Let's go over to the other one and here do service. Let's see, we had these here. Restart. You can see the status here, and it's up and running. So now when this is up and running, if I go to shared FS, it's not mounted on this machine. And let's see if shared FS is not mounted on that machine either. If we tail the var log messages, see here. So now we see that it's up and running, and we have it good here. So let's see if we stop the heartbeat on the first machine here. Then we see here on the second machine that it notices that the primary machine is not up and running, and then it will take action and make itself primary, and then try to bring DRBD up. And you see here DRBD mounted file system, DRBD data mode opts null. And if we go to shared FS here, we see that we have lost and found here on the second machine, which now is primary. The first machine, if we tail our var log messages here, we see that heartbeat has been shut down. So this is not the primary machine anymore. If I now touch a file here, let's say testing if working. So now I have a new file on this file system, and I should leave here. Let's tail the logs again. We go in on the first machine and I do a service, heartbeat start. Now we see that this notices that it's no longer the primary, so it will move over to be a secondary again. And then it will note that the node have completed standby takeover for foreign resources. So now the other node, VM1, is the primary node. If we look in shared FS, we see that we have testing if working here. And if we do the same here, that we go to shared FS, it's not mounted anymore. So now we have switched over who actually has the responsibility of the data. So we have switched between the machines, and this gives you some opportunities. If you have this setup and you need to do some maintenance, you need to update, for instance, PHP, or you need to update Apache, or you need to do some configuration changes, or whatever you are running on your system, you need to do some maintenance. You can update it on this secondary machine, and when you are done and you have tested the configuration and see that everything is working, then in a good moment when you don't have that much traffic, you can go into your first machine. Let's create a directory here called year. And then when you're done with your configuration, you stop the heartbeat on the first machine, making it available to you. And then you have the second machine up and running, and all your data is here ready to take on users. At that point, you only have one running machine, but you have still are able to make changes to the first machine, update things, and when you are done, you will just start it again, and the service will be switched over to your primary machine again, and you have this fall over. If the primary machine could have a critical failure, it will go down, it will burn up, it will disappear. the second machine can just go on working. And in order for this to work well, of course, you need a load balancer that can actually give the IP or the different services the right load, or actually send the traffic to the right machine depending on. And if you have an intelligent load balancer, you can actually send information from Heartbeat to it, so it knows which machine to actually send the traffic to. So this was what I wanted to cover today. I hope that you found this interesting. I hope that you learned something today. If you are using any failover technique on your machines at work, or if you have tried any other techniques, please leave a comment down in the comment section. Or if you have any questions or suggestions, leave them down there as well. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.